Hello, welcome to Mrs. Metzler's Pre-Calculus Honors class. So glad you could join us. Hi guys, sorry for the delay in the video this week. We came to our house in the mountains and there's been a few internet issues. So here we go, here are the notes. The good news is this is exactly what we've been doing, only I find usually students find it easier. Now granted, I've been giving you the answer so you could check yourself. Just realize with simplifying those trig expressions, you usually don't know when you're done. We're in a different situation, so that's why I've been giving it to you. So the only difference today is that you're verifying them. You are showing that one side of the equation equals the other. So you're given the answer, per se. In a sense, the answer really is you proving that one side equals the other. So a good first strategy in this case is to choose the more difficult side to work on. Okay, so for example 1, obviously the left-hand side is the more challenging than the right-hand side. So we are going to work on the left-hand side, LHS. Okay, and then the same strategies as we did before. Change whatever you can to sine or cosine. And so we know secant is 1 over cosine minus cosine. And I'm not going to keep writing equals sine squared. I know that's where I'm supposed to be going. And that I'm just going to write the reason still for today, just because, again, I know this is challenging. That was because of one of the reciprocal identities. How do you, we could either subtract in the parentheses, but I have to distribute this anyway, so I'm just going to distribute for this second. It wouldn't matter, it wouldn't matter which one you do first. If you want to make a common denominator, that's acceptable as well. But I'm going to distribute. So I'm going to distribute cosine to here. That means I have cosine theta over cosine theta minus cosine times cosine gives me cosine squared theta. What do I know about cosine over cosine? It's simply 1. So now I have 1 minus cosine squared theta. And if you look at your trig ID sheet, one of your Pythagorean identities says that 1 minus cosine squared is sine squared theta. Okay? So like I said, this is where we were going because we worked the left-hand side and we got there. All right, next one. Which side do you think is easier, left or right? Okay, pick the harder side. In this case, it's the right-hand side. I see some fractions and a whole bunch of junk going on over there. Okay, so how do you subtract fractions? Common denominator. Take 1 of everything. So 1 minus sine x and 1 plus sine x. Now remember, you play the what's missing game. So what's missing in the left-hand fraction? That would be a 1 plus sine x. And now remember, here's where it's tricky. You have to subtract everything over here. So what am I missing on the right hand, right here? What am I missing from this denominator to my new denominator? The 1 minus sine x. And remember, I'm just writing what's missing because I have 1's as my numerators. So that's not going to change anything. Okay, now, what do you want to call it? Simplify, subtract, whatever. You got to distribute that negative. So subtract or simplify. So I still have 1 plus sine x. Now it's, oops, sine x. Sorry, sine x minus 1 plus sine x. Right? Distributing this, subtract to here and here. And still over the same denominator. 1, oops. Oh, I didn't click it, sorry. 1 minus sine x and 1 plus sine x, same denominators. Okay. Oh, look, easy enough. 1 minus 1 gives me 0. And then what's sine x plus sine x? So we're going to simplify a little bit on the top. And then I'm not getting anywhere on the bottom. And remember, think now, you know where you're going, absolutely. You know you're trying to get to tangent and secant. So I'm going to FOIL that bottom. Let's see what happens. Sometimes you need it, sometimes you don't. You just got to try. So on the top, sine x plus sine x gives me 2 sine x. Remember, not sine x squared. What's x plus x? And on the bottom, after I FOIL that, I get 1 minus sine squared x. I simplified it a little bit. I didn't show every step, but I did FOIL it. What is in the bottom of tangent? Sine over cosine. What is in the bottom of secant? 1 over cosine. You know anything about 1 minus sine squared x? Look at your Pythagoreans. It's actually Pythagorean identities. It's actually the opposite of 1 we just did up there. We know we need some cosines in the bottom. So let's change it to cosine squared x. I think we're almost there. Oh, I messed up. Not with that. I wrote cosine. Sorry. It's still 2 sine x. Sorry. Okay. We know tangent is sine over cosine. We know secant is 1 over cosine. So I don't know the exact mathematical terminology here. We're just going to say, I'm going to say split it up. I think it's multiplication. So we can say 2 times sine x over one of the cosines times another one of the cosines. As long as these two are equivalent, we can do whatever we want. And look, we're there. Use your reciprocal identities. 2, we know sine x over cosine x is tangent x. And we know 1 over cosine x is secant x. And that's where we were going. That, I gotta scroll, matches that. Right here. Boom. Okay? Alrighty. And I think I got one more example for you of these. It's a good one. And it brings in a new topic we haven't done, so that's why I wanted to do it. So, which side do you think? Left-hand side, right-hand side? Right? There's no rhyme or reason as to which one you pick. You can choose whichever one you want. In this case, I'm purposely going to pick the left-hand side to show you something else that we haven't done yet. If you think back to the fall, when we had to rationalize rational functions, if we had something like this, to get rid of that denominator, we had to multiply it by this, right? 3 minus the square root of 5, and that was called the conjugate. So that's the concept we're going to use here. We're going to work the left-hand side, LHS, and is there anything you can see we can do to cosine or sine? Remember, our good usual first strategy is change anything to sine or cosine. Nope, already got sine and cosine. The next thing you're going to say is, oh look, 1 minus sine, that's a Pythagorean identity. It is not. Those Pythagorean identities must be squared, and we don't have anything squared. So we're going to multiply by the conjugate of the bottom. And that's purposely why I wanted to show you this one, because I don't think this has come up yet in any problems. So we multiplied by the conjugate. Multiply, conjugate. Multiply, whatever, sorry. Okay, and so cosine times 1, cosine x, cosine times sine, cosine sine. And sure, let's do the bottom too. Who knows what happens. So FOIL the bottom, right? So 1 minus sine squared x. Okay. We distributed and FOILed. Again, look what we got on the right-hand side over here. Look what we're trying to get to. We're trying to get to a secant and a tangent. What's in the bottom of secant and tangent? Kind of like the last example we just did. We know in the bottom of that is cosine. So let's use our Pythagorean identity and change the bottom to cosine squared. Cosine squared, sorry. So now we got a cosine squared in the bottom. We're getting closer. What do you see in both the terms in the top? They both have a cosine, right? Didn't we do that up here? Up here in this step, we distributed it. Is that a word? I don't know. Sometimes, you might distribute it. Sometimes you might have to undistribute it. Again, these problems just take practice. So we're going to pull out that cosine back in the top that we distributed a few steps ago. And so we're back to what we had. It's okay, who knew? So we pulled out the GCF. Now, what if I had this problem? X on the top and x squared on the bottom. How do you reduce that? Well, you take out one x of each, right? And end up with 1 over x. I'll apply that same concept to cosine. And so simplify, cancel, however you want to think of it. So I have no more cosine on the top. I just have this. And I have only one cosine on the bottom. Remember, you can only cancel or simplify like this when everything's connected by multiplication. This guy is connected to this by multiplication. And in the bottom, it's only one term, so it doesn't matter. All right, let's think back where we're going. Secant plus tangent. I think we're there. Split it up again. So 1 over cosine plus sine over cosine. Remember, that's a common denominator. It can apply to both. It has to apply to both. It does apply to both. So then use your reciprocal identity. 1 over cosine, secant, sine over cosine, tangent. And that's where we were going. Okay? All right. I know this is a lot, guys. I'm trying to keep it as simple as I can. Like I said before, I think I debated even going over this topic, but it was honestly essential, good word for these days, essential to anything else we had to learn. Okay? So your assignment's up there. Email me, call me, text me, whatever. If you're listening to this on Friday, wear your seatbelts, and for goodness sakes, wash your hands. Bye.